All right, so in this video, we have a point and we want to find primary trig ratios for this point, and we also want to find the value of the principal angle between 0 and 2 pi. So the first thing you want to do is you want to sketch this point out in the right quadrant based on your x and y axis. So my x value is 6, my y value is 8. You should be able to tell that that's in positive quadrant 1, positive x and y value. You can draw a triangle over here now. And the x value is 6 and the y value is 8. So we can use Pythagorean theorem to find our hypotenuse over here. So c squared equals a squared plus b squared. C squared equals 100. So basically my hypotenuse is 10. So now I can find my primary trig ratios. So primary trig ratios are sine theta, cos theta, and tan theta. So sine theta is just opposite over hypotenuse, which is 8 over 10, and this can be simplified to 4 over 5. Cos theta is just adjacent over hypotenuse, which is 6 over 10, which can be simplified to 3 over 5. And tan theta is opposite over adjacent, which simplifies to 4 over 3. And finally, we want to find the principal angle. So in order to find the principal angle, we can do sine, cos, or tan inverse of any of these. So I'm just going to do the tan inverse of 4 divided by 3. And make sure your calculator is in radian mode. So if I do the tan inverse of 4 divided by 3, I will get 0.93 radians if I round to 2 decimal places as my principal angle, basically starting from this line and going here, which is the same as the acute angle, just in this case. Let's go to our second example. The point is -12 and -5. So again, I'm going to start by just sketching this out. -12 and -5 is in quadrant 3 because two negatives. My x value is -12, my y value is -5. I'll do Pythagorean theorem again to figure out my hypotenuse. So c squared equals -12 squared plus -5 squared. C squared equals 144 plus 25. C squared equals to 169. Square root that, I will get my hypotenuse as 13. Again, now I can do sine theta, cos theta, tan theta. So sine theta, remember the principal angle starts here and goes all the way till here. We pretend like it's this acute angle in the triangle when answering our questions. So sine theta is opposite over hypotenuse, which is -5 over 13. Cos theta is adjacent over hypotenuse, which is -12 over 13. Tan theta is -5 over -12, opposite over adjacent, which just simplifies to 5 divided by 12. Now again, you can use any one of these three to solve for the acute angle. So when you're solving over here, you want to not put the negative signs in so we can find the acute angle first. So let's say I'm using sine, of course, because tan doesn't have any negatives. Let's say I'm using sine. I'm going to do the sine inverse of positive 5 over 13. Don't include the negative because this is going to give us our acute angle. 5 over 13. So I get my acute angle to be 0.39 if I round to 2 decimal places. And now to find my principal angle, if I start here and go to here, this is pi and then plus 0.39. This is basically 3.54 radians rounded to 2 decimal places. Okay, let's go to the third example. Third example is 4 and -3. Again, let's start by sketching it out. X value of 4, y value of -3 means I'm in quadrant number 4. 4, -3. I can find my hypotenuse by doing Pythagorean theorem again. So c squared equals 4 squared plus -3 squared, 16 plus 9, just 25. So my hypotenuse is just 5 in this case. Then I can do sine theta equals opposite over hypotenuse, so -3 over 5. And we're pretending like it's this angle, although the principal angle is all the way this one over here. Cos theta is adjacent over hypotenuse, which is 4 over 5, and tan theta is opposite over adjacent, which is -3 over 4. Then I'll find my acute angle first. I'll do the tan inverse of positive 3 over 4. Put that on my calculator, I will get 0.64 radians. I know this is 0.64 right there. And then I know a full circle is 2 pi, so I'm going to do 2 pi theta equals 2 pi minus 0.64 to find my principal angle. And I get 5.64 radians if I round to decimal places. Now this last point here, this is a trick question, and I'll tell you why. So the point is 0, 5. I'll do a little tiny diagram here. If I actually draw 0, 5, it doesn't lie on any quadrants. 0, 5 is right there, but you can't draw a triangle and solve the question using the triangle like that. So I'm going to show you a little trick so you can do this question. But remember, this diagram is not accurate. I'm actually going to label 0, 5 over here in the first quadrant. You could have done it in this one as well. It doesn't matter. Any of these two would work. And I'm going to draw my triangle like this. I'm going to label my x value as 0, and I'm going to label my y value as 5. This is going to help make things a bit easier. So again, I'll do my Pythagorean theorem. So c squared equals 5 squared plus 0 squared, c squared equals 25 plus 0, c squared equals 25, which means that my hypotenuse is 5, which makes sense because if you look at this line here, this is both the opposite and the hypotenuse, which has a length of 5. So now I can do my trig ratios. So sine theta is opposite over hypotenuse, which is 5 divided by 5, which is just 1. Cos theta is adjacent over hypotenuse, which is 0 over 5, which is just 0. And tan theta is 5 divided by 0, opposite over adjacent. This is basically infinity or does not exist. And that makes sense because if you do tan of pi over 2, it's going to give you an asymptote basically in the calculator. So for example, I know that if I let me find this solution here. Let's do theta equals to sine inverse of 1 to solve this one here. And remember, theta and beta are the same in the first quadrant. So you can find theta straight away. You get pi over 2. And pi over 2 is a vertical asymptote for tan, which means tan cannot exist for that case. So that's what we get does not exist for a tan ratio of infinity over here.